My esteemed listeners, in this video tutorial, we bring out the second version of space and time trade-off strategy, namely the pre-structuring. This is yet another technique that exploits the space for time trade-offs, and it usually, like the other version, it also uses extra space, but to facilitate the faster or more flexible access to the data. Typically, the techniques that are discussed under pre-structuring will be enabling a database management system with huge number of keys, okay, and it will provide a different table or different allocation table or different space wherein the keys are stored and which can be accessed very easily. There are two important problems that are addressed by the pre-structuring version of the space and time trade-off. It is hashing as well as indexing with B trees. Okay. And in this tutorial we will discuss about hashing. This comes under pre-structuring. As I told, it uses extra space to facilitate more faster access to the data. It is a technique. Hashing, by the by, is a technique to assign the keys of a database management system in a one-dimensional array, namely H 0 to m-1. It consists of m number of cells and this one-dimensional array is called as hash table. The keys are stored over here in this small package of cells, and so much so that the keys can be accessed very easily, and the keys are allocated. So this is the cell, this is the array consisting of 11 cells, and here huge number of keys can be stored methodologically or methodically with the help of the pre-structuring version of the space trade-off. And this is coming to be called as a hash table, as I told earlier, and the allocation is made to each and every cell by means of a function called as hash function. The assignment of key to a particular cell is made using hash function. Hash function looks something like this. Hash value for a particular key. The cell number for a particular key is equal to value of the key mod m, where m happens to be the number of cells. If the key is an integer, that itself is the value, and mod operation is done, modulo division is done, and we will be able to obtain the cell number. And if the key is a string, the value of the key is computed by just adding the ordinal values of all the alphabets available in the key. For example, if it is ABC, A1, B2 and C3, so 1 plus 2 plus 3 is the value of the key, and that is divided by m, and the remainder is taken out, and that remainder happens to be the cell number. If the key is an alphanumeric consisting of alphabets as well as numerals, then the key value will be equal to sum of the numerals plus the sum of the ordinal values of the alphabets present in the key. Okay, so finding key value is not at all a problem, and it is divided and it is modulo division, and the remainder of the modulo division happens to be the cell number. There are two requirements of a hash function. Of course, these requirements are a little contradicting, but anyway, it is said that the distribution of the keys is to be uniform. Naturally, that means to say every cell should get equal number of keys, preferably. For this sake, the denominator, that m, the divisor, happens to be the prime number. Okay, here m is a prime number, so this prime number will promise uniform distribution of keys. And the second requirement of the hash function is the function is to be easy to compute. Okay, they are contradicting. Anyway, since we are trying to push several keys in a big database management system into a small number of celled array, okay, consisting of m number of cells, naturally collision will occur. So it is possible that multiple keys will be assigned to a particular cell. This is unavoidable. Anyway, there are two mechanisms to avoid this collision and to distribute the keys to the respective cells. The two methods happens to be this is a hashing methods. Two principal versions of hashing methods happens to be open hashing, which is also called as separate chaining, and the closed hashing, which is also called as open addressing. So in this tutorial we will discuss threadbare about open hashing. Okay, open hashing, keys are stored in linked lists. Of course, every cell will consist of a header pointer, okay, assigned to each and every cell, and that will connect the linked list. And therefore the linked list will be hung to each and every cell, and it will be attached to the every cell. And each and every linked list attached to a cell will be provided with a pointer, and that pointer will be able to translocate over that linked list. So we'll take a typical example and we will just find out see as to how the keys can be attached. So given list of keys 50, 10, 59, 75, 21, 18, 16, 17 and 22, and hash function is h of k equal to k mod 11. Therefore number of cells happens to be 11. And therefore we will calculate the hash value. Okay, hash value we can calculate directly over here. Okay, hash value of 50 happens to be equal to 50 mod 11. 50 mod 11, that is percent. I will use this symbol. Okay, percentage 11. So 11 fours are 44. 11 fours are 44. What remains is 6. Therefore 50 should go to the 6th cell. H of 10, that is hash value of 10 is 10 mod 11. 10 mod 11. So it has to go to 10, cell number 10. And 59, h of 59 in the same token, okay, should go to 59 mod 11. That is how we compute. Okay, and we will get 59 4. Okay, and h of 75 is 75 mod 11. 75 mod 11, it will be 9. Then h of 21 mod 11, it will be 10. And h of 18 will be 18 mod 11. 18 mod 11 will be 7. Similarly, h of 16 will be 16 mod 11. It is 5. The cell number is 5. Similarly, h of 17 equal to 17 mod 11. 17 mod 11, that is equal to 6. So we have computed all the values of the cell numbers to where the keys are to be attached. So now we will just attach. So this is 0th cell, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we should remember the fact that whenever any number is divided by a divisor, which happens to be and if it is a modulo division, then the numbers generated out of this modulo division happens to be 0 to m minus 1. Okay, this is a thing, fundamental thing. So 50 is attached to 6, and then 17 is also attached to 6. Okay, 50 comes first, therefore it is attached to a linked list node. So 50 will go over here. Then another number that will go to 50 is 16 or 16, 17. The 17 will also go over here. Okay, and as far as 50 is concerned, it will go to 6, 10 will go to 10, okay, 50 will go to 6 and 10 will go to 10, 10 will go to 10, 50 we have already attached, so this is 10. So like this we can go on attaching and there is no clash as such, and we have got independent cell numbers for these things. Okay, so it's only the sixth cell, and the 10th cell will be able to get two keys. One is 10, the other one is 21. Okay, the other one is 21. Rest of the keys will be independent and they will be existing in independent cells. And if naturally, if number of keys happens to be much more than this, it's of academic interest. In reality, the number of keys will be very much big. Therefore, number of keys will be definitely more than the value of m. And anyway, it's not going to hamper our allotment because each and every cell consists of a linked list. To a linked list, as you know, any number of keys can be attached. Now we'll take another typical example wherein the keys happens to be the words and the entire string consists of is a meaningful string, but anyway let us not bother about that. But anyway, the keys here are alphabetical in nature. Okay, now similarly we have to calculate, like earlier we have to calculate the mod function is k mod 13, therefore we will calculate the hash value for each and every string, each and every key. H of a, the ordinal value of a is 1 mod 13, so we will get 1. Then h of fool, FOOL, is the cardinal value of f. The cardinal value of f, that is 6. The cardinal value of O, that is 15 plus 15, and the cardinal value of 12 mod 13. So it is 15, 30, 30 plus 12, that is 30, 32 plus 42, 42 plus 6 is 48, 48 mod 13. So this will give us 9. Okay, the hash value of fool is 9. Similarly, hash value of R and hash value of AND happens to be 6. Okay, hash value of his happens to be 10. Money, hash value of money, okay, it should be calculated in the similar fashion. Okay, the ordinal value of m plus ordinal value of O, ordinal value of n, and ordinal value of e plus ordinal value of y, and money will go to 7, cell number 7. And h of r, okay, we will calculate with a special interest. Okay, legitimately, h of r is a is 1, okay, r is 18, the ordinal number, and e is 5. So this gives us mod 13. Will give the cell equal to 11. Similarly, h of soon also happens to be equal to S is 19, O is 15, another 15 for another O, and for N it is 14. It is mod 13. So this will give us the cell number to be 11. So there is a clash over here. Soon and R will occupy the cell number 7. Okay, and H of parted happens to be 12. Therefore, in a typical sense, A, so this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We will end up there because number of cells happens to be 13, because 13 is the denominator and that is in the function. 1 will receive R, which will be in the node, in the information compartment of the node, and there is only one node over here. And a fool will go to 9. Okay, fool is here. Okay, fool is here, and a fool and his money will go to 6, and will go to 6. And his will go to 10. Money will go to 7. Money will go to 7. Fool and his money are soon parted. R will go to 11. This first node in the linked list, and soon will also go to the second node in the linked list. So the length of the linked list as far as cell number 11 is concerned is 2. It consists of 2 nodes, and parted will go to cell number 12. So this is how allocation is done. Anyway, there is no question of open hashing. Will simply avoid any possible collision because every key will be allotted to an independent cell. So naturally, when searching for soon happens, soon the key value of the hash function value, of soon will be calculated like earlier, and it will allocate the cell number 11, and for this one comparison is to be done. So one comparison to find the cell number 11, and we will compare with R. R is not equal to soon. Anyway, the comparison will happen over here also. So therefore 3 comparisons will take place whenever we want to search soon. Like this, any number of keys can be attached independently without collision. Therefore, the efficiency of this kind of hashing is measured by what is called as load factor. Okay, load factor is given by number of keys divided by number of cells. And this ratio is often called as alpha. This is called as load factor. Load factor preferably or desirably should be same for all the cells. In successful searches, the load factor, the number of this load factor plays a crucial role, as I told you earlier, in the efficiency of hashing. In particular, the average number of pointers, that is chain links, inspected in a successful search S and unsuccessful search U turn out to be S equal to 1 to find the cell divided by alpha by 2 in a successful search. The number of links visited, and in an unsuccessful search it will be simply equal to alpha. Okay, this is the efficiency of the open hashing. It is open because the linked lists which are hung to each and every cell are visible. Okay, it is externally located. Only after finding the value of the key that is to be searched or that is to be inserted, we need to visit that particular cell. making use of the header pointer available in each and every cell, the link can be just traversed. The entire list can be traversed, even for searching as well as even for insertion. So with this, we completed the first technique, that is open hashing technique, which comes under the umbrella of pre-structuring version of space trade-off. And you will very well appreciate that we definitely used extra space in order to store the keys, and this extra space happens to be very small in its volume. That is, it consists of only m number of cells. It is one dimensional array basically, and it is called as a hash table. Okay, naturally so much of keys which are available in a database management system are packed very efficiently in this particular kind of hashing, and searching for a key is very easy. Searching of a key is very easy. Therefore, we have traded off the space in order to improvise our searching, or in order to speed up our searching procedure. Once the key is found, the entire details of that particular key can be driven out of the database management system, and we can take a printout, or it can be flashed on the screen. So with this, we have completed the first example of this pre-structuring, that is hashing. In that hashing, we have discussed open hashing over here, and in the next video, in the next tutorial, we will come up with closed hashing, another technique. Until